Alright, so today we are starting our next and last unit of the semester, and this unit is going to be over circuits. Okay, so this is Unit 5, circuits, electric circuits. And of course, electric circuits are around us, all the time, every single day. So I want you to think for a second, what are some examples of electric circuits that you use, or that you experience, or that you see every day? Okay, so circuits show up all over the place from, and there's circuitry inside your cell phone, inside any electronic device, but also when you plug something into the wall and use power from the wall, you're also creating a circuit. Okay, and we all have wires running through our homes that are basically all part of one giant circuit. Okay, and so we're going to start off by talking about what are some things that you need to make an electric circuit. And so there's some components that we need to talk about. Okay, so a circuit basically works by moving electrons around a closed path. Okay, and so all circuits have to have a certain number of elements. Okay, so number one, you have to have conducting material. Okay, by conducting material, I mean like typically a metal is what you think of when you think of like a conductor, as opposed to something insulating like rubber or glass or plastic. Okay, so you need some type of conducting material. Okay, something made of metal usually. You have to have a closed conducting path. And when I say closed conducting path, basically I mean a path where you can go all the way around without any openings in the path. Okay, so for example, here you can see there's a closed conducting path in the circuit on the left. If I were to take away the paper clip, then there would be a gap in between the battery and the light bulb, and I wouldn't have a closed path anymore. Or if I were to take some scissors and cut the wire right here, then I would not have a closed conducting path, because then there would be a gap where I cut the wire. Okay, so you have to have a closed conducting path. And then finally, you have to have what's called a voltage source. We'll talk more about that in a few minutes. Okay, but all circuits basically have to have those elements. A conductor, and I said before, like usually when you think of a conductor, you're talking about like a metal, but a conductor basically has what's called free electrons inside its atoms that can flow and make up the electric current. Okay, so you have to have that. You have to have the closed conducting path, because otherwise the electrons can't flow, because there might be like a gap in the space. Okay, so I said before, like if you were to cut the wire, then you'd basically have like electrons that can't go anywhere because they're stuck at the edge of the wire, and they can't just like fly through the air. Well, they could fly through the air hypothetically if you had enough voltage. Okay, but normally in a circuit, you don't have enough voltage for electrons to just fly through the air, because that would be a lot. Okay, so just to give you something to play around with, I have a simulation that I will link in. Okay, and so you can use the simulation to kind of build your own circuit. Okay, and so just to show you a really simple circuit here, we have, a battery, of course. And so this is what's going to be my voltage source. And then I need some wire. I need like conducting material. Okay, and so I can take the wire and I can connect it. And if I connect these two ends together, then that's actually bad, and it says animation speed reached. Okay, and I actually don't want to do that. What I just did a second ago is what's called a short circuit. Okay, and short circuits are bad. You might have heard of a short circuit before. They can be really dangerous, because then it produces a lot of heat inside the battery, and then the battery can like explode and get acid over you, and that's not good. Okay, so basically in your circuit, you have to have something using up the energy. Okay, so for example, you could have like a light bulb or something like this, and when I notice that when I don't have a closed path, nothing is happening. When I close the path, then you can see the electrons start to flow in the circuit, and the light bulb turns on. Yay! Okay, so that's a very basic circuit. And so if you want to play around with the simulation, make your own circuits, then, have fun with that. Okay, so let's talk about some physical quantities that we need in order to do circuits. Okay, so I said before, in an electric circuit, you typically have charged electrons moving around a closed conducting path. Okay, how quickly they flow, the rate of their flow, is what is called electric current. And you might have heard that term before, current. Now, the symbol for current is a capital I. I don't know why, but it is. Okay, so capital I is the symbol for current. The unit for current is what is called the ampere. It's named after a French physicist whose name was Ampere. And usually what people will say like in everyday language, instead of saying ampere, they'll say amps. And so if you've ever heard anyone talk about amps before, that's probably talking about current. Okay, and so if I had a current of, let's say my current was like 5 ampere, I would write that I equals 5A. Okay, so we put a capital A for ampere because it's named after a guy. Okay, and so current has to do with like how quickly is charge flowing per second in a circuit. Okay, how quickly are the electrons flowing per second? Okay, so on the next slide, we're going to use this analogy where we imagine like water running through a pipe. And before I show you that water flowing through a pipe, you might be asking like, why is it electrons flowing and not like protons or neutrons? And the answer to that question is because like if you imagine an atom, the electrons are on the outside of the atom, and so they're more they can move more easily. Okay, so in case you want to know why is it electrons flowing in a circuit and not like anything else, that's why. Okay, so this slide is basically just talking about current again. Okay, but to go back to the water analogy, so here on the left you can see a picture of a pipe, and there's water kind of trickling out the pipe, not very quickly. Whereas in the picture on the right, you see there's like a big flood of water coming out from the pipe. Okay, and so the picture on the left would represent a small current, and the picture on the right would represent a big current. Okay, so current has to do with the stuff actually flowing through the pipe and how quickly it flows. Okay, so in the water analogy, the current would be made up of the water. In an electric circuit, the water, quote unquote, the current is made up of electrons. All right, so that is electric current. Now, what is it that makes the water flow? What is it that forces the electrons to flow in a circuit? Okay, so this has to do with what's called voltage. So in order to force the electrons to keep moving in a circuit, you have to have what's called a voltage source. Okay, and voltage is actually really complicated to explain what that is, and so I will just kind of give you the gist. Voltage is roughly related to electric potential energy. Okay, and so current, that is moving electrons, go from high voltage to low voltage. Okay, and so if you have like let's say like a battery, let's say you have like a AA battery. If you look at it on a AA battery, it says 1.5 volts on it. Okay, and one side is the positive side and one side is the negative side. Okay, the positive side has a higher voltage and the negative side has a lower voltage. And basically, you can imagine like the negative sign is like 0 volts and the positive side of the battery is like 1.5 volts. Okay, and so voltage is basically causes the force that pushes the electrons around in the circuit. Okay, the symbol for voltage is a capital V. Kind of confusingly, the unit we also write a capital V for because the unit for voltage is the volt, because it's named after a guy whose name was Volta, and so that's also a capital V. And so if I had a voltage of, let's say, let's say I have a 12 volt battery, like a car battery is like 12 volts. Okay, I would write that V equals 12V. Okay, where this V is voltage and this V is the unit, which is volts. Okay, so this is like the only thing in physics where like the unit and the symbol are like the same letter. So it's kind of strange. Okay, and as I said before, voltage is what causes the current to flow because what happens is the electrons want to go from a high voltage to a low voltage. So they get lifted up to a high voltage and then they kind of naturally try to get back down to a lower potential energy. And just to show you an analogy, this right here is basically just showing you the symbol and the unit. These are two common batteries. This is a 9-volt battery. This is a AA battery, and if you look closely, you can actually see it says 1.5 volts on a AA battery. Okay, so if you ever use anything that uses batteries, each of those batteries is 1.5 volts, and then you can like put them together to like increase the voltage. And so if you had like your TV remote and it has two AA batteries in it, if you put two AA's together, you get 3 volts because you get 1.5 plus another 1.5. Okay, so that's what causes the current to flow. And in the water analogy, if current has to do with how much water is flowing, voltage has to do with what is making it flow to begin with. So for example, here you can see um, in the analogy, like it's the height of the water that causes the current to flow, right? Like the more it's kind of like water pressure. If you can imagine like water pressure, like the more pressure you have, pressure is not something that flows, but pressure is what causes the flowing. Okay, so it's kind of the same with current and voltage. Okay, so current has to do with what is actually flowing, those electrons flowing. Voltage has to do with what is causing the flowing to actually happen. Okay, so here you can see like high current, low current. The voltage is high for both of these, but here, like in the analogy, the voltage has to do with the height. Okay, and so I said this before, but voltage is what makes the current flow. And so as the charge moves around the circuit, what happens is the battery kind of acts like a pump to pump the electrons up to a higher energy level, up to a higher voltage. And then what happens is the electrons try to flow to get back down to a lower energy level. Okay, so for example, here you can see that the positive side of the battery is here at the top, and what happens is the current comes out of the positive side, and then it tries to get back down to a lower voltage, and so it keeps going until it gets back to the negative side. Now you might ask, like, once it gets to the negative side, like, why does it keep going up to the positive side of the battery? And the reason for that is batteries have like chemicals in them, and they release chemical reactions, and through those chemical reactions, the electrons get extra energy to move back up to a higher voltage. Okay, so batteries use chemical energy to make that happen. Okay, but it is kind of like a pump mechanism if you think like you pump the charge up to a high voltage and then it naturally flows back down to a low voltage and then it gets pumped back up again by the chemical energy inside the battery. I'm going to link a short video. I want you to watch the first 3 minutes of the video. It's just showing like a really nice animation and explaining some concepts that might be useful for you to know for circuits. Okay, so we've talked about voltage and we've talked about current. Okay, so based off of the concepts we've talked about so far, try to answer these two questions. First question, as the voltage in the circuit increases, the current flowing in the circuit will blank. Okay, and second question, as the voltage in a circuit decreases, the current flowing in the circuit will blank. Well, based off of the concepts we've been talking about, voltage is what pushes the current around. And so if you increase the voltage, of course, you're also going to increase the current. And if you decrease the voltage, you're also going to decrease the current. Okay, that should be like a kind of common sense type of thing. Now, current and voltage are related to each other as we just talked about. And there is an equation that relates current and voltage, and that is what's called Ohm's Law. Okay, and here is what Ohm's Law looks like. V is voltage equals I, which is current, and then this thing called R, which is called the resistance of the component of the circuit. Okay, so we know V is in volts, we know I is in amperes. R, that's resistance, has an interesting symbol. The unit for resistance is what's called the ohm. But the way we write this is this like upside down horseshoe looking thing. This is a Greek letter omega. Okay, so the unit for resistance is ohm. Okay, so if I had a resistance of 5 ohms, I might write like R equals 5 ohms, and then I would read this as ohms. Okay, it's named after a guy. I don't know why it has that symbol, but it does. Okay, so Ohm's law basically relates voltage, current, and resistance. Okay, so let's take a look at some examples. Okay, this chart right here basically just kind of summarizes the three things we've talked about: voltage, current, and resistance. And you can see like the symbols and the units for everything. So pause it there if you need to add that to your notes. Okay, so I said this before, but resistance is measured in ohms, and it basically has to do with how difficult it is for current to flow through a device or through a component. Okay, so more resistance means it's harder to make current flow. So that means, let's say you had two objects and you wanted them to have the same current. The one that had a higher resistance would require more voltage to get the same outcome. And here you can see like a cute little cartoon kind of like symbolizing, voltage, current, and resistance. Like voltage is what does the pushing, current is what actually is like moving through the wire, and resistance is like what prevents the current from flowing. Okay, so let's do some simple calculations with Ohm's law. That's our V equals IR equation. Okay, so example 1. It says the voltage across the light bulb is 1.2 volts. Okay, so this is V. If the current that flows through the light bulb is 0.02, remember A is ampere. Okay, so this is current, so I'm going to label this I. It says calculate the resistance of the light bulb. So very basic calculation with Ohm's law. V equals I times R. The voltage is 1.2 volts. The current is 0.02. R is being multiplied, and so to get R by itself, we need to divide. And so in my calculator, I'm going to do 1.2 divided by 0.02, and I get 60 ohms. Okay, so the resistance of this light bulb is 60 ohms. Okay, so that is example 1. Pause it there if you need to look at that some more. Okay, example 2. So try to do example 2 on your own. Example 2 says a 9-volt battery is connected to a 50 ohm resistor. Okay, a resistor is like a little circuit component. You can buy it at like Radio Shack, or you could buy it on Amazon or whatever. But basically, it's like this little tiny component that you can put in the circuit to do stuff with. Okay, so this resistor has a resistance of 50 ohms. And it says calculate the current that flows through this resistor. Okay, so pause there and try to do example 2 on your own. Okay, so again, we have the voltage of the battery. We have the resistance. We're looking for I. I use Ohm's law, V equals I times R, and I plug in. I is being multiplied by 50, so I want to divide both sides by 50. And so I do 9 divided by 50, which is 0.18 amperes. Okay, so that is it for example 2. Pause it there if you need to look at that some more. And let's just take a look at one more quick example. Okay, example 3. Here we have a picture, and you kind of have to tell from the picture what's going on. But it says use Ohm's law to calculate the current that runs through the resistor in the circuit shown to the right. So this is our first look at a circuit diagram, and we'll see more of these as we go throughout the unit. Okay, but pause it here and try to do example 3 on your own based off of what we've talked about so far. Okay, so Ohm's law, V equals I times R. I have the voltage of the battery, which is 10 volts. And I have the resistance of this thing. This thing here with the squiggles, this is the symbol for what's called a resistor. I talked about this before. Okay, you'll need to be able to recognize that symbol. That's a symbol for a resistor, but we know what that is because of the unit. Okay, 5 ohms is the resistance. Okay, so this is 10 equals I times 5, divide by 5, divide by 5, and you get I equals 2 amperes. And so the current flowing in the circuit is 2 amperes. Okay, later on we'll talk more about like how to understand this picture and what's going on, but basically this is just like a simple circuit with a battery attached by some wire to a resistor. Okay, but we'll talk more about circuit diagrams later on. All right, so we're going to go ahead and stop it here. As always, please let me know if you have any questions, and I'll see you guys in the next video.